Hey folks, a quick announcement before we dive in. Fragmented now has an email newsletter. It's a fun one where I share behind the scenes stories on how I came up with episode ideas, motivations, plus glimpses into future plans. If you like email newsletters, please subscribe and even more importantly, send me your feedback. I genuinely care about what you think, what's working, what's not. Let me know, please. That's it. On to the show. Welcome to Fragmented, a podcast where we capture what's top of mind for Android developers. I'm your host, Kaushik Gopal. Today, I want to talk about programming paradigms and specifically about one paradigm called data-oriented programming, or DOP. I came across DOP recently, and it really invigorated my passion as a software developer. I haven't been this excited about an approach since dabbling with RX and functional programming, in the recent past. But before we go any further, what is a programming paradigm? Object-oriented programming, or OOPS as we have come to love and learn, that's a programming paradigm. Functional programming, that's another programming paradigm. The goal of any programming paradigm is essentially to manage complexity. But complexity comes in many forms, and not all paradigms handle all forms of complexity equally well. If you look at object-oriented programming, for example, the key concept is that everything can be modeled as an object. It excels at modeling real-world entities with different complex behaviors and relationships all within your object. You can combine state, behavior, everything and package it in a nice object and just be on your way. Object-oriented programming basically encourages you to do this. You are successful with this paradigm when you define and defend those boundaries in your program. They have concepts like encapsulation and all of the other things. Functional programming, on the other hand, excels when dealing with data manipulation and calculations, where things like immutability matter. Pure functions are crucial, especially in situations where you have a lot of parallel processing and concurrency going on. It provides a reliable way in these scenarios or situations of just sending inputs in and deterministically getting something out. The key word here is functions, right? Because, functional programming. So what about data-oriented programming, or DOP? The good news is, by the way, before I even start any of this, DOP can coexist with all of these other paradigms that we have come to love and use. This isn't a replacement or like a new hammer for us to just attack all things with or see everything as a nail. Data-oriented programming is a paradigm concept that you can judiciously use in addition with all your other programs. It's just a tool that forces you to think more critically about how you represent your data. Now, if object-oriented programming is all about objects, everything is an object, and functional programming is all about functions, everything can be modeled as a function, DOP is about, well, you guessed it, data. It's about making your data representation as the top priority. And the key to understanding DOP is basically understanding the weight that they put in behind that term data. It's not the thing that you take casually. They're very, very particular about what you call data. The representation of your data becomes the most important thing in this paradigm. On first reading, by the way, it can be a little vague, but the more and more I read about it, it started to click. And I'll point you to all the resources that I used over the course of trying to come up with this episode, because I assure you, I don't think I can do full justice in just this short time that we have together and through the audio medium. But I'll try to at least leave you a little more curious about the topic at the end. But before I go any further on extolling the virtues of data, I almost feel the better way to make this click immediately is to take a simple example and illustrate how one might think about data or model data in the world of data-oriented programming. So let's take the simplest example. Say you have a simple bank transaction class. Every bank transaction, it's fair to say, requires an ID, right? Or an identifier. How would you model this? Just, with this years of object-oriented programming driven subconsciously in our heads, if you were to come up with a simple, representation, how would you model this data? You would say a data class bank transaction and maybe throw in a value, throw in a property called ID of string, right? By the way, in this episode, I've tried to do something a little more particular. Please take a look at the screenshot in the show notes so you can just quickly take a look at some of these code snippets and grasp what I'm trying to explain. I'll try to keep this very simple. You're not going to be looking at some complex program. I just want to be able to illustrate the point a little better. So as a simple attempt at this, you can have a data class called bank transaction and a property ID declared with a string type. That seems totally reasonable on first glance. But if I were to put my DOP hat on, there's immediately a bunch of questions that are screaming at me. Let's go through some of them. Look at that ID. The first question to ask yourself is, okay, that's an ID of string. Should it be unique? Well, it's a bank transaction, so I sure would hope so. So that means now, associated with this bank transaction class, somewhere in my program, I will have to include additional logic that makes sure that this ID remains unique. So already there's one doubt. I look at this data class, this innocent data class with an ID string, and already that ID, it feels like there's a lot of logic, associated logic that will have to be buried in my program to take care of that data representation. Here's another question. We say that the ID is a string. That means I could technically put a number inside it. It's a string, but what if I represent the string 42 or 93 or 20 or 19 in it? It doesn't feel right? I can store a representation of a character, of a number. What is the format of this string? I need to know for a bank transaction ID. I can even store special characters. Hey, it's a string, whatever. Now, if it were a bank transaction, I would guess you don't want to go all crazy in there. If that's the case, I will need associated logic that checks for these conditions. That business logic has to live somewhere in my program. In the object-oriented programming world, this is totally fine because you can add those conditions as validation logic in functions or methods and just throw them into the same class, right? And that's how they become an object. An object is a combination of different properties and associated method or functions that hold logic that protects the sanctity of that object. Oh, by the way, here's another question. Are these IDs monotonically increasing? Or because they're a string, I don't know, how do you generate a new ID and make sure that the other conditions aren't violated? There's just a ton of these questions you can keep asking about this simple declaration. But data-oriented programming, DOP, basically says your data needs to be much more representative. All those things that we talked about really should be represented directly in the data. You shouldn't stare at a piece of code and then have 50 or 20 questions about the data itself. You should avoid also the need to use more functions and logic to guard that data. You shouldn't have to look at a whole bunch of functions to understand or reason about the properties in that data. Okay, all this is great. What should I do? Take a look at the screenshot again. I'm going to make a small change to that type that we declared. Instead of string, I'm going to be using UUID. What if I just made that one small change in how we represent the bank transaction data class? Suddenly, with just a little more thought, if I put in just a little more advanced thought into that data class, our type here is doing so much more work. The data now automatically captures all of that logic. I don't actually even need to have a whole bunch of the other logic that we talked about with those other questions, right? Because let's go through some of those questions. Is the ID unique? You betcha. One of the U's in UUID literally stands for unique, right? So that question is answered. I look at that and I'm like, yeah, of course it's unique. I don't need to worry about it. Now, do the IDs have a format? Absolutely they do. UUIDs in general follow RFC 4122. I just looked that up online. That's the official format, which is whatever it is, a 128-bit value represented by, 32 hexadecimal characters in 5 groups. That's the format. We all know, I don't look at a UUID and think, oh, wait, can I store numbers, characters? Immediately in my mind, I understand what a UUID format should look like. By the way, quick tip, Kotlin now includes UUID in the standard library as of Kotlin to some beta version. I'll add links, even for Kotlin multi-platform, which is pretty cool. Side tip. Okay, do you notice the change? With a little more upfront thinking in modeling our data, for something as simple as an ID, we have in the process eliminated a whole bunch of logic that you would otherwise have to write to sort of guard and keep the sanctity of this data. You don't have to worry about uniqueness. You don't have to worry about what the format is. It's not masked behind a string. It's a very specific format. And, as a programmer, again, I look at that UUID. I kind of know how to generate UUIDs. A lot of those questions that were asked are simpler to answer. Now, does that mean that this is the best and that's the end of the story? No, obviously not. There could always be questions. There's always more logic that you have to associate, and we can come to that in a second. But at least it's so much more info is packed by just changing and being more deliberate with the type that we chose. The point I'd like you to take away from this example on data-oriented programming is that you often discover that well-modeled data means you have to write fewer elaborate defensive methods, as we like to call them, in your business logic. Because you've taken the time to model these data objects so well, it alleviates the need to write these defensive methods. Okay, let's take another example. Say you have a basic network API. You could just have an API that takes in a request and prints out a response object, generic response. And then you would, again, litter a whole bunch of places with defensive logic. Does the response object have an error? Then maybe it's an error. Did it time out? I don't know. Let's see, the full response. Was it chopped? Was it interrupted by any stretch? I don't know. Was it a success? Well, maybe it was a success. Did it, after getting a successful response, have an empty object, or did you actually find a result? What if we modeled into the API all of these results? What if we took some time to think about how you could model this API and put all the possible combinations of responses that you expect in a sealed class or a sealed interface? Take a look at the screenshot again in your show notes. What if my network result, instead of just, a response object, a simple result object, had 4 specific subtypes as part of the sealed interface? So there's a network result. I could have a success response and a success network result. And if you look at the property in there, I put match search result. We'll come back to that in a second. I could have a success, which is the happy path. I could have a failure, which is the straight up unhappy path or the failure case. But I could also have a timeout or interrupted. And this is where that if you put in a little more upfront investment in how you model the API, you can come up with a much more expressive API. There's, of course, other questions, which is hey, does your API even support this? What if my network API doesn't even tell me if something is interrupted or not? That's not the problem we're tackling here, or the point I'm trying to make when it comes to data-oriented programming. The exercise for you here is, if this was the API that you had to contend with, assuming that your network API gave you this result, wouldn't this be so much more nicer to deal with? I don't have to check for some vague error or timeout because they're all explicitly modeled in a sealed class. So when I get a network response, I almost know that there is no other possibility. There's only 4 possibilities: success, failure, timeout, or interrupted. That logic is immediately clear to me. In this way, we explicitly model out any ambiguity from the code. And this is the key point with data-oriented programming. It's a very important concept and one of the benefits of thinking this way. It almost feels now there's no erroneous or unexpected or unambiguous path in my code because all the possible results are right there in a sealed class. And because it's a sealed class or a sealed interface, I have to contend with it. My program needs to respond to it in a certain way. And this is the key point on how DOP succeeds, they're all just sealed classes. Now, you can again be a shitty programmer and not handle those cases properly, but at least the programming paradigm encourages you to think about how you have to model this problem. In some ways, the code also becomes really easy. You use this API, I don't really have to worry about what might happen. The model or the data tells me exactly what to expect, right? So if I'm a programmer, usually very experienced programmers think about all the different edge cases that might happen, and account for these to build a stable program. But when you put the upfront investment in modeling the data again, I actually don't even have to worry that much because all the possible responses are just right there. They're modeled in the data. Let's take that example a step further. Even in the search result that we get, if you notice the screenshot before, again, I added like a match type. That match API can again be modeled more explicitly. Let's take another similar-ish example. Say I was building just a find API. Take a look at this screenshot again in the show notes. Instead of just returning, a result, or say even if I go a step further and say, hey, I have a find API and it gives me an optional result, right? Which means it's either null or not null. Instead of something like that, I can explicitly model all the permutations of a search match right into the data object. For example, I may actually not receive a match at all. Search for something, nothing found, 0 results. I could explicitly model that as no match, meaning no results found. I might receive an exact match, which is the happy path, right? I issue a find or a search, I get a single result, the exact result that I was looking for, exact match, happy path. I might even receive a fuzzy match, which is like I didn't exactly find what you were looking for. I found a bunch of things that were similar, right? Or a similar result. Let's take the singular case, a fuzzy match singular result. It might give me the result that it thinks is similar. It could also give me an accuracy result or something like a distance parameter, which tells me how far away from the original search my result was. I could also get a list of these results, like fuzzy matches in plural, right? Because I search for something and maybe you have 10 results that all sound similar. I could model all of these things all within the same match. And again, when you look at the screenshot, look at each of the result types. No match has nothing. It has because there isn't a result. Exact match has a result with of type T, which is like it's expecting one object of type T. So in this way, if I had an API, a find or a search API that gave me a match of something, like say in the same screenshot, I gave a very simple code snippet where I say find user and the result is actually match of user. In my actual code, when I get the result, I know for a fact that all these cases have to be handled by me. I have to handle the option of not getting a match, getting an exact match, getting fuzzy match, getting a list of fuzzy matches. There isn't this point where you have to think about these different things and handle this and show different parameters. It forces you, the data being modeled so carefully, forces you to think about how you have to account for these different parameters. Now, again, this requires a lot of upfront work, more in terms of thinking about your program or your business domain. It's not just a technical thing where you have to think about the technical possibilities. Of course, there's some of that, but you really have to understand your problem domain really well. You have to put in a lot of that initial work. And, one of the books that I'm reading on this also tells that the very first step is actually kind of a painful step, which is you got to talk to your colleagues. You have to collect a lot of the institutional knowledge, put all of that, and that's how you come up with a really good design. That's how you model a really great data that you're aiming to do. All right. How do we go forward from here? I hope you've gotten sufficiently intrigued by data-oriented programming. I don't expect you to understand every nuance. I'm going to provide resources for you to do just that. But hopefully, I want you to walk away understanding a few benefits that you get by switching your brain to this approach of data-oriented programming. One, your programs become immediately descriptive. They're just so much more nicer. When you look at the code, it immediately tells you so much more than what you would have otherwise done if you were putting an object-oriented programming hat. Your programs also become simpler. A lot of the work is done upfront in modeling your data. So after all that upfront work is done, really the rest of your program is just dealing with much, much more simpler logic. All of it is just a whole bunch of switch case or when in the case of Kotlin statements, because you've modeled all of those types. So it's all about you just, iterating through all those different sealed class types and handling those conditions explicitly in the way that you want your program to. But lastly, the other major benefit, and this was where I had my aha moment, was when you model it really well, you model away or model off the existence of incorrect states. You don't have to worry that your program has a bug because an incorrect state was encountered that you did not handle in code. You just simply don't allow the representation of that ambiguous state. So there's no need to worry about writing a condition where, the wrong response is received or not. So those are some of the immediate benefits that I would like you to walk away thinking when it comes to data-oriented programming. If I were to step back and just hey, high level, give me the 2-minute snippet of what data-oriented programming as a whole is, it really just boils down to a few concepts. One is just model your data with a lot of thought. Make it as expressive and expansive as possible. And second, you want your program eventually to be just a bunch of these simple expression types. And the simpler objects or components that you have are all just a bunch of switch case or when statements. Because again, this is when you start to read, at least initially, a lot about data-oriented programming, the question that'll keep gnawing at you is if I don't put my logic in this data, if I'm not allowed to put behavior logic or business logic in my data explicitly, or I'm not able to model it in some ways, what am I supposed to do? Where do I put that logic, right? And with object-oriented programming, it's so simple because you can just throw it as part of an object, group it all nicely packaged in one object, and you're off to the races. But that hides some of that ambiguity. And data-oriented programming forces you to think about these things. But assuming you cannot model it in your data, what they encourage in data-oriented programming is something similar to what you would call a visitor pattern of sorts. You have these explicit components or these objects that in turn handle just the data. So it almost takes in just that explicit data and it handles it explicitly. And again, folks listening very carefully can then start to wonder, wait, isn't this sounding very similar to functional programming? It is. I'll come back to that in a second. But one of the things that I found in my research is the seminal article on data-oriented programming was written by this person named Brian Gates or Brian Gotts. And he has some guiding principles. It's an excellent article. It's really well written. I'll link it in the show notes, of course. But there's 4 guiding principles of data-oriented programming as he posited. The first guiding principle is model the data, the whole data, and nothing but the data. Each of those pieces actually mean a lot of things. Anyway, that's the first guiding principle. The second guiding principle is data is immutable. And this is really important. I didn't touch as much in some of the examples and the concepts I've talked about, but it is extremely important for your data to be immutable. It needs to live and needs to be represented by its own. You should be able to pass this data around and it shouldn't lose its identity in the process. I didn't touch too much into this, but some of the resources I linked to will really, dive into this. So data being immutable is a very important principle or guiding concept. The third is validate at the boundary. This also becomes a very important principle. And this moves more in the philosophy of, hey, model out all the error conditions. So if you are creating an object, one of the things that you're encouraged to do is, hey, if you really want to make sure that some of these crazy conditions shouldn't be possible, do that at the boundary. Don't let that possibility seep into the logic and carry over into, the rest of your program. Right when you encounter that, and that's what they mean at the boundary, validate that logic at the boundary. And so some of the code examples that you'll see in this article is, in your constructor itself, they add object required, not null. Again, some of this code is Java, so there's much more elegant ways to do this in Kotlin. But that's the philosophy, which is as soon as you get a input parameter, if that does not follow what you expect in your domain, validate or throw an error and reject that immediately. So that's what's meant by the third guiding principle, which is validate at the boundary. The fourth one is make illegal states unrepresentable. And I touched on this in some great detail, which is like, hey, model out all the error conditions, right? And this is the part that I found really resonated with me. And, these are loaded terms. Like when he says model the data, the whole data, and nothing but the data, each of those expressions, the whole data, nothing but the data, they actually mean a lot more than what just meets the eye. If you folks are interested, I'm happy to do more follow-up episodes on just some of those individual pieces, or I can try to write blog posts or content. So please let me know if you want more clarification on that. All right, let's go back to this other question, this lingering question that you can have in your mind. Isn't this, and honestly, I had the same question when I looked at data-oriented programming. I kept asking myself, isn't this just another way of writing object-oriented programming code with, a twist, say like the visitor pattern? And in some ways, those expressive types that, we talk about in the data, they look very similar also to algebraic data types. Like, if you've done a little bit of Scala, some of us, have dealt with the library Arrow, and that a lot of that is very similar to functional programming. Like those concepts are really drilled in, especially like algebraic data types. They're drilled in with the concepts of functional programming. To this, I'll say one thing. As programming languages evolve, things that you had to explicitly model and call out as specific patterns just become second nature. They become easier. And it's on you to leverage those patterns. But the beauty in all of this is it all just becomes simple. I'll give you a separate example. Now that we live in a world where lambdas being a first order type is second nature, right? You don't even think about this. So many of your Kotlin programs pass lambdas as parameters. We just casually use it in all of our programs. But do you ever stop to think, oh, wait a second, what I'm really doing here is a behavioral pattern as expressed by the gang of four, blah, blah, blah. You don't think of it like that. You just use it, and that mechanism becomes simpler. You're using a lot of these patterns, but you're just doing it because the language now allows you and makes that so much more simpler. And with Kotlin, and honestly, Java is also evolving and getting there, some of this newer functionality enable these paradigms. The concept of data-oriented programming is more like an evolution where, given that you have some of these really powerful tools in your language, you can adopt a pattern that otherwise was a little more difficult to do. This is at least how I square it away in my mind. I don't like to put too much weight into like these things and call it a new separate thing. And in all fairness, a lot of the proponents of data-oriented programming, they do this really well. They make it very explicit that, hey, we don't want you to think about this as something new that you have to now start using everywhere. It's another tool and a way of thinking of software development that has some very clear and explicit benefits that you should leverage. All right, before I close, I want to point you to some really good resources on this topic and some quick takeaways. First, I'll link Brian Gates, might be butchering his name, that seminal article. Fantastic article. Start there. Start by just reading the article. If you don't understand every single nuance, it's fine. You'll get a lot of what he's trying to convey from that article. Second, T.S. Van de Ven gave a really nice introductory warm-up like talk towards data-oriented programming, and I'll link to that. It's on YouTube. It's for the event Advanced Kotlin Dev Day. The book that I briefly mentioned in this episode is perhaps one of the best books around data-oriented programming. It's actually called Data-Oriented Programming in Java by the author Chris Kyle. And it's the funny thing is it's from this publisher called Manning, their famous book publisher. And the book is not even complete. So it's in the process. I went ahead and bought the book because I was just so deep in my research. And I will say so many of that aha moments I got from reading this specific book. So this book is incredible. I would encourage all of you to read it. It's in the process of also being written. So, take that for what it's worth. And lastly, there's this other fantastic DevOps talk by Nikolai Parlog. It's also on YouTube. This talk uses, it's again more specific to Java, and it talks about some of the new language features like records, seal classes, as I talked about. But as a Kotlin developer, you can totally follow along. These things at this point are like second nature to us. So fantastic talk. I think if you just cover these resources, you are in great hands. So, and lastly, if you go searching the internet, as I did, you will inevitably run across very similar sounding concepts. So one, there's data-oriented programming. That's the thing that we talked about today. There's also data-oriented design. And this is sort of a programming paradigm that's used more for games. It's a technique that's used in games for just high-level performance and optimization. Very, very different from data-oriented programming. Unfortunately, they sound so similar. The only difference is programming and design, but they're very different concepts. So don't confuse the two, because I've actually seen articles out there that confuse the two concepts. Please don't be confused by that. And lastly, there's data-driven programming, which is what a lot of these languages like awk and sed, SED, AWK, these Linux tools, which just define patterns to match and process data streams. I call these out because in my process of researching this topic, I ran across these, and sometimes it was only halfway through the article, like when I was reading something, I realized, wait a second, these are just completely different from what I was looking for. So data-oriented programming, or DOP specifically, is the thing that you want to spend time looking at least in the context of this episode. I hope you all found this useful. I went down a deep rabbit hole on this one last month, but I'm very grateful. I emerged extremely happy and invigorated, as I said, that I now have this new tool in my belt. Thank you all so much for listening. Stay curious, keep learning, and keep sharing. I'll see you in the next one.